Here's how to calculate the tonnage of a cooling coil that's utilizing water or 40% propylene glycol using the universal hydronic formula. First, let's start with water. So you have a cooling coil here doing 480 GPM with 45 degree entering water temperature and 55 degree leaving. And here is the universal hydronic formula. First, let's look at water, then we'll look at the glycol solution. The universal hydronic formula is Q in BTUs per hour times 500. We'll talk about what that means in a minute. Times GPM times delta T. So we carry down the 500, we multiply by the GPM and the delta T, and we get 2,400,000 BTUs divided by 12,000 BTUs per ton comes out to 200 tons. So this cooling coil at this GPM, this delta T with just water is doing 200 tons. Let's look at propylene glycol. Okay, so we're going to be using this as an example. It's 40% propylene glycol pre-mixed. I think I could take these gloves off now. It's hot. So the important thing to know is here, where does this 500 come from? So this 500 breaks down as follows for water. Its density, which is 8.33 gallons per pound, times a conversion factor, 60 minutes per hour, times the specific heat of the fluid, which in this case is water, which is 1 BTU over pounds degrees Fahrenheit. The important thing to note is these values, the density and the specific heat, will change with temperature and will change depending on what type of fluid you're using. For standard conditions like these, it's acceptable to use 8.33 gallons per pound for water density and 1 for the specific heat, but those values will change with temperature. Now, what happens when we add glycol to the system? So the density is going to change. So this is the density of the 40% propylene glycol that we're using. This sheet came direct from the manufacturer since it's pre-mixed, which is 8.51 gallons per pound. Now this will change based on temperature. I don't see a temperature rating on this sheet. Typically these are at 60 degrees, so keep that in mind if you've got temperatures that are far off from that. And the specific heat of the fluid is going to change. Now this specific heat will change based on temperature as well. I'm using 0.88, which is the specific heat of this solution at 50 degrees, which is roughly the average of these temperatures. If we multiply out these values, we get 450. So we'll replace the 500 with 450. So now we have 450 times 480 times 10, which equals 2,160,000 BTUs per hour divided by 12,000 to convert it to tons, which is 180 tons, which is less tonnage than the water solution, which is what we would expect. I want to thank the folks at Peak for sending over this pre-mixed solution so we could provide this demo.